to the LeetCode question, and we'll see the approaches. Okay, so this is 1143 LeetCode question number, and the question is the longest common subsequence, in which we have given two string, string 1 text 1 and string 2 text 2. Then we have to return the length of their longest common sequence. If there is no common subsequence, then we have to return 0. And so we have to understand what first we have to understand what is the sequence. Okay, so it is saying that a subsequence of a string is a new string generated from original string with some character and can be non-deleted without changing the relative order of the remaining character. For example, if this is a example, if a string is ACE, right, ACE, and is subsequence of ABCDE, means how we have to understand this one. Okay, so let's give me 1 minute to get the pen. Okay. So the first string what we have, the first string we have ACE. Okay, and other is what, A B C D E. Okay, so if we talk about this A, this is A at the index what, 0. Then in the other string it should be from 0 to what, the next element, right, to the last element, you can say last index. So A should be in the string this. Okay, A should be in the string what, from index 0 to, from index 0 to the last index, it should be in that. Similarly, if we'll talk about C, right, the index C is at what, index 1. So the C should be between 1, right, between one index and the last. Okay, and the last. So C is at what position? C is at second position, right? This is the position of C, that is a 2, and that is okay. We are we are fine with that, because we need, C should be in which index, between 1 to the last, because he is at index 1. Next, if we'll talk about, and A is already at the same position, right? A is at the same position, 0 position, and this is at 2 position. Next, if we'll talk about this one, E, that is at 2, right? So it should be at what position? After 1, that is between index 2, from 2 to the last position. Okay, last index. So E is at what position? 3, this is 3, and this is 4, this is 4th position, right? It means, yeah, this is the substring of this one. Similarly, the text is given ABCDE and text 2 is given in the example 1, and that's why it is returning ACE. What? ACE, total number of output, because ACE has the length what, 3. Okay. Next, if we'll talk about example 2, we have ABC, both are exactly same, the subsequence will remain same, and so the output is same. But if we are talking about the example 3rd, in which we have ABC and DEF, there is no matching, correct? There is no matching, and that's why we are getting output 0, right? So let's understand first the overview, okay, and then we'll talk about the program. So first understand what is a common subsequence, right? I have given one example. We have given 3 examples in which I have shown you how to understand it. Let's begin with this example in which we will understand the longest subsequence. Okay, how we will find. So if string is given like this and another is this one, if this is S1 and this is S2 string, right? So if we start from A, right? So A is not into the B, right? Here A is not into the B in the position of starting position, right? So we are getting what? We are getting at from here to here you can see we are not getting. Where C will check, that is also not there, right? Now then we see T, right? So T is starting. That's why here you can see we have starting T, and we map that this T is already available, okay, in this one. So we are okay with that. Next element what we have? Next element we have 9 G, sorry, okay, and G is also in which position? G is at this one, okay. So we are not considering this one, this G and this T, right? We will consider this one, okay. What? This one. And then this is the A, and that is here, right? Because this T is already at what position? This position, right? That we have seen. Now we are checking G. G is this position. A is this position, right? Because a common subsequence is a sequence of letter that appears in both string. Not every letter in the strings has to be used, but the letter cannot be rearranged. In essence, a subsequence of a string S is a string we get by deleting some letter. So if we delete this letter, right? If we delete this letter from the string, right? Then what we will get? We will get TGA, and that is here. That is we have in the string first. Okay. And let's see. We'll see the next, right? So if we'll talk about this one that we have already seen, right? This one. So we got T, G, A in the string 1 and 2 both, right? So this is the subsequence we are taking, okay. Next, if we'll talk about this one, if we'll start with this T, right? This T, and then this T, and then this T, right? 3 possibilities we have, right? And then we'll talk about G. We have this G, then this T is along with this G. So T and G is along with them. This T and this T, and this G and this G. Okay. So here, if we'll talk about what we are getting consecutive, we are getting T, T, T. Okay, right? T, T, T. We are getting. Here we are getting G, right? And here what we are getting? We are getting T, T, G, right? But what we should not take as a common, these lines should not cross, right? If we have taken T in the first string, so in the second string, if we'll consider this one, right, means we are taking this one as a first string, okay, first common, right? We are taking first common. We have prioritized this one, and this is this. But you are seeing that G should not match with the rest of right, okay, right, because if we will take G, right, it means this will cross this line, this common line, okay. So we should not cross this. We can take any of this one, this letter, any of this, and that will be our common sequence. But if we'll cross like this, then this is not the going to be a common sequence, subsequence. And here if we consider this one A and this is okay, but on for this one, like if we are considering this one, so this will not work because this is crossing the TG connection, okay. So drawing line between the corresponding letter is a great way of visualizing the problem, and is potentially a valuable technique to use on a whiteboard during an interview. So observe that if the line cross over each other, it means what? This is not a subsequence, right? And if not, then it represents the common sequence. So because lines that cross over are representing letters that have been rearranged, right? So we will use to refer lines between the words extensively throughout the articles. So there are multiple examples we can see through the brute force we have, greedy we have, right? So you can see that if we'll talk about this example, right? We are starting initially what? A, and this is the string S1, and this is string S2, right? So here we have A. Similarly, if we'll talk about A and C, right, this is head, right, and there is a gap, right? There is another, we are skipping this one, we are escaping this one, right? and we are considering this. So this is, here we are getting A and C, here we are getting only A. If we'll talk about this one, we are getting A, C and G. Okay, so here we will get A, C and G, and there is no crossing line, there is no crossing line. Similarly, if we'll talk about this one here, right, we are getting T, G, A, G, right, this is, there is no crossing. We can go like this, but this should not cross, the crossing should not be there. Here you can see that we are getting G, T, T, sorry, G, G, okay, G, T, G, we are getting G, T, G, okay. There is no cross, right? But never do like this. Like we should not cross all the possible line, right? Like we are doing zigzag like this, cut. There should not be that, like that. This should be like this. This should be like this, right? And the combination of that. But it should not cross like this. Cross should not be here. So we can apply dynamic programming memorizations in different programs, right? So let's understand first the initial program. Okay. Here. So first we will consider the program that we have recursion with the memorization. Okay, recursion with the memorization, in which what we are taking, the function is longest common subsequence, in which we are passing text T1 and text T2. Okay, and two things will calculate m and n, the length of the text. Then we will take a cache memory where we will store the calculated value, calculated subsequence, you can say common sequence, and there is a utility function that will do recursive. Okay, so this is the purpose of recursion. So we will take a recursive function, okay, and that will calculate the common subsequence. So as you can see, we have text 1, text 2, I and J and cache memory, okay, to store the calculation. So if the length, this is the base case, right? If this is the base case, if the length I and J is I or J is greater than equal to what, at the last index, means we do not need to do anything, we will return 0. We will return what? 0. Next we will check in the cache, if cache not equal to null, means we have already calculated, so we are not going to continue, we will return from here only, from the memory, we will return from the memory. If both are common at index I and J, right, what we will do, we will do 1 plus I plus 1 and J plus 1 with the same function, we call recursive util, and I plus 1 and J plus 1 we will return. Then we will return, okay, and we will, at the time of storing into the cache, how we will do that? How to do? We will do max. We have to prioritize the max between these and these. Means what? Here we will take I plus 1 in the argument. Here we will take J plus 1. Okay, and remaining will remain the same. I plus 1 and J plus 1. Okay, which one is better? Which one is max? That will come into the cache, and then we will return cache of I and J. That will go to here, right? Because we are doing recursive call, right? So it will return the memorization. So this part of the program is called what? Recursive with memorization. Okay, and this another approach we will talk about, in which we will see that the DP. Okay, so I have written at one place, and I'm doing here. So as you can see here, right, what we have, the longest subsequence we have program 2, in which we are taking m and n index, and the DP m plus 1, like we have the cache, right? We can say the cache also, but this is DP, so that why I'm using DP keyword. Okay, now we'll start from I 1 to m and J 1 to n. Okay, in which we will see the caret I minus 1 and J minus 1. It means index 0. We will taking at index 0 in the both string. If both are equal, means what we will do? We will do 1 plus dp of I minus 1 J minus 1. Okay, we will take dp of I minus 1 and J minus 1. Else what we will do? We will take the max of I minus 1, j minus 1, and we will store in the dp of I and j, dp of I and j, and we will return finally what? After doing this for loop, we will return dp of m and n. Okay, so this one dp of m and n we will see here. I think you understood, right? The recursive, in which recursive we have to take in the recursive, if I equal I at index I and j is what equal, then we will do 1 plus and then we will take I plus 1 and j plus 1. And if we are in the dp we will take 1 plus I minus 1 and j minus 1, right? Okay, only this is the difference. And to get the maximum value, I plus 1 and j plus 1, in which we will get the max that will come into the cache memory. But if we'll talk about this one, we'll take I minus 1, j minus 1, I minus 1 and j minus 1. Which one is big? That will come into our dp of I minus j. So let's understand the dp things. So as you can see here, we have two approach, right? We will see plus 1 and a max 1. See, if we'll start with the g, right? So how we calculate? We calculate if we have g and g in the string 1 and a string 2, right? This is s1 and this is s2, s1 and s2. If both index is same, right? If both index is same, what we'll do? We'll do 1 plus 0 equal to 1, right? That we are doing in the dp, right? So we will increase one more value, right? How? If that is not equal, what we will do? Max of 1 comma 0, that is called whatever the max will have, that will come. Similarly, if we'll check with t is not equal to g, then we will do what? Whatever the maximum we have, that will come. Similarly, we'll take t and g, then we'll check, and similarly we'll do like this. Okay, so which one is the max, right? That will come into we will store into dp, and and then we will increase I plus I and j value until it will go to what? It will go to the last index. Okay, here like this. Okay, so this is our final dp calculations, and we will return the dp value. So if you want to go through the optimized way, right, this program, so please ping me in the comment box. I'll start with the optimization.